Assalamu alaikum students. Today our topic is related to energy. What is energy? Energy in your again the previous class, ninth class, you have read that energy is simply defined as capacity to do work. Capacity to do work. Or you will say the ability to do work. So if a body is having more ability to do work, we are going to say it is having more energy. If a body performs less work, we will say it's having less energy. And the SI unit of this very energy is that is joule. And if you are going to take the dimensional formula of energy, dimensional formula, dimensional formula, that is simply m1 l2 t minus 2. That is the what I mean to dimensional formula of the energy. Now, right now we are going to discuss about the kinetic energy, which is in your syllabus. What is kinetic energy? Simply energy because of motion of the body. Motion of the body or object, that's known as what? Kinetic energy. So for example, if you are having flowing water, uh, if there is you will say bullet which is fired from the gun, that's having the kinetic energy. You are going to see the vehicles moving, they are having the motion and they are having the kinetic energy. So anything which is going to move, that is having the kinetic energy because of it is motion. So energy because of motion of the body, that's known as simply kinetic energy. Now if we're going to see the expression for the kinetic energy, for example, if we are having a box here, a block here, and this very block is here, it is of mass m, and we are going to apply a force F on this very block, and initially the block doesn't have any kind of velocity, it is at rest. So after some time, if this very block is going to move here, it's going to reach here somewhere. If it is going to reach here, and its velocity is now v. So first is velocity u, that is equal to 0. Now its velocity is what? Its velocity is, and it has traveled through a displacement or distance of s. So because of the application of force, as we consider a body of mass m initially which is at rest, let's apply some constant force F on this very body, so that there will be acceleration. Once I am saying there will be acceleration, so there is change in the velocity, and I can say uh, on the application of force there will be F equals to m and a, where m is the mass of block and a is the acceleration. But let after some time, as it achieves a velocity of v, then I can use the formula like this: v square minus u square equals to a s. But as the initial velocity is 0, so I can say v square equals to what? 2 as, or which implies a comes out to be v square over 2s. Now if I will use this value of a in this very equation first, so what will it become as? Then F, the force applied on the body, equals to the mass times velocity square divided by 2 into s. So since the force applied produce the displacement in its direction, then the work is done by the body, then I can say the work done W equals to force into S, the displacement. Force is here, that is m v square by 2s into the s, that is displacement. This s and s is going to leave, what there resides, that is W. W comes out to be W, the work done comes out to be 1 by 2 m into v square. So this work done on the body appears in the form of kinetic energy. So thus kinetic energy of body is half the product of mass of the body and speed, the square of the speed. Kinetic energy depends upon the mass as well as the velocity of the body, speed of the body. Here you have to remember one important thing. So you can say this kinetic energy is a scalar thing, as this is the mass and this is simply the speed. And kinetic energy of body depends upon the speed, not on velocity. You have to remember. For example, if you are having a circular motion, uniform circular motion, all of the speed remains same, but the velocity is going to change. But what has been found? It has been found that kinetic energy of body having uniform circular motion remains constant. That is, if a body is in a circular motion and its speed is, let it be, 2 meter per second, but its direction is going to change continuously as it moves. So once its direction changes, then its velocity changes, then there should be change in its kinetic energy. But its kinetic energy doesn't change. That only implies that it is the velocity, it is the speed, not the velocity, because speed remains everywhere same, but what changes, that is the direction. So in uniform circular motion, the kinetic energy remains same, can remain only same if it is speed. If it is velocity, then it cannot remain same, so it is simply speed. So since speed and mass both are positive, so kinetic energy of body is always positive. You have to remember it. And this is how we can change the kinetic energy of body. Either we can change the mass of the body, or either we can change the speed of the body. So thus kinetic energy is defined as half the product of mass of the body and square of the speed of the body. This is all for today. I'll be with one other lecture. Till then, Allah Hafiz.